This video clip explains how to write and use exponential equations from descriptions, like words describing what's going on. An example, fast-growing strain of bacteria doubles in population every hour. Each bacteria splits and becomes 2. So if you start out with 100 of these bacteria, the function below can be used to find P, the number of bacteria, the population of the cells in this culture after T hours. So if they wanted to know what is the total number of bacteria after 3 hours, we can use that exponential equation. The T is in the exponent, 2 raised to the T power. So we would write P equals 100 times 2 raised to the 3rd power. So on the calculator, we would do the exponent first, 2 raised to the 3rd power, that's 8, times how many we started with. We started with 100. So after 3 hours, we would have 800 bacteria. Or you could multiply 100 times 2 3 times. But as the exponent gets larger, it's quicker to just use the exponential function on your calculator. Another common application of exponential equations is with investments. So if Melinda invested $1,000 in a retirement account, the formula below shows the amount of money, A, that will be in her account at the end of T years. So in the formula, R is the interest rate expressed as a decimal. So let's say she gets 4%. So what is the amount in Melinda's account at the end of 5 years? Well, if the rate is 4%, then the amount will be equal to how much we started with, $1,000, times 1 plus, the rate is 4%, or 0.04, raised to the time, number of years, and the question asked, how about after 5 years? So that can be simplified a little. So we go to our calculator, and let's do the exponent first. 1.04 raised to the 5th power times the number of dollars that we started with, 1,000. So that would be $1,216.65. So let's say Mr. Lee purchased his car and it had a value of $20,000. Each year its value decreases by 9% in value. So cars often become less and less valuable. If the value of Mr. Lee's car continues to decrease each year by 9% of the previous year's value, what will be the value of his car 5 years after he purchased it? Now we could just find out what 9% was and subtract that each time, but let's use an exponential equation. So we'll say the value of his car started out at 20,000, and then we multiply by 1 minus the 9%, 0.09, raised to the 5th power. So we start out with the original value, but we take away 9%. So the value is 20,000. And 1 minus 0.9 would be 0.91. If we do that subtraction first, that should make it easier for the calculator. We grab our calculator and we say 0.91 raised to the 5th power. So it's only worth 91% as much as it was each year for 5 years. So that says it will be 62% of the value, 0.62. So we multiply that by the original value, 20,000. Then it should be worth $12,480.64. Check our calculator, 64 cents.